Begin with our last session, that is Environmental Studies for Sustainable Energy Resources and Development. I invite our chairpersons, Professor Hema Achyutan Madam and Dr. Bishwajit Thakur. Professor Hema Achyutan Ma'am and presentation by Ms. Shamoli Sen and Sivakumar. It's our pleasure to have with us Professor Hema Ma'am, who has done extensive work in quaternary geology. So I like to invite Hema Madam to please give the keynote address.
Respected Rasik Ravindra Saab, Dr. Nigam, my dear friends, elders and seniors from Geological Survey of India and the other organizations, and my dear students, it gives me immense pleasure to be here in Nagpur, and I thank profusely Madam Samaya Humne for this kind invitation to be here amongst you all and speak to you all about the work that my students and myself we are conducting in southern India, particularly with lake and lake sediments. During the course since morning, you would have been hearing that there are a number of proxies that you can use to reconstruct the past. But how past is past? How far you can go back in time? And for this, you need high resolution data to be reconstructed. And the proxy records should nearly take you to the truth. And then alone, your data can be compared both on a local scale, on a regional scale, and also on the global scale. There have been a number of short extreme events, like what we saw with the publication from BSIP, where you had the Roman warm period, or the MWP, or the LIA, or the Dark Ages. But these are in the last 2,000 years. But if you can go back still further in time, the best proxy where you can use are the lake sediments. Not everybody can get onto a ship and get a sediment marine core, where the resolution of the sediment layer in the ocean floor or on the seabed using foraminifera, which lives only 2 days to 2 years, or some of the species which live up to 14 years, they become a very high resolution study for quaternary period, which spans about 2.8 million years. But on a terrestrial record, you can use the lake sediments. And even amongst the lake sediments, even amongst the lakes which are at a higher elevation compared to the coastal area or in the floodplain area, they become more reliable in collecting and working on your sediments. So let me just give you a glimpse of what we have been doing. We have been looking up at some of the late quaternary paleo-environmental reconstruction using lake sediments, particularly in the Nilgiri and Ooty area, where the lakes are located at a higher elevation, something more than 1,800 meters above sea level, and we are also comparing them with the coastal lakes. For example, from Kerala, the Velayani Lake, or the Ashtamudi Lake, and several of them, or the Paripakara near Thrissur. You know that India is endowed with one of the most important and wind system, and that is the monsoon. And you all know that the word monsoon is derived from an Arabic word, mausam, which means seasonality, a season. You have every year rains starting from Kerala, moving north and spreading all over the Indian region, and then picking up the moisture from Bay of Bengal, picking also from the Ganga plain, and coming down directly south, hitting the lower region of the Andhra Pradesh and the Tamil Nadu coast. It is only the Tamil Nadu coast and the lower region of Andhra Pradesh from Kakinada, that's for me? Thank you. It receives the northeast monsoons. For many years, I was thinking how to delineate between the southwest monsoon and the northeast monsoon contributions that are coming into the lake systems. But it is little difficult how to delineate them. But what we see is this, that the monsoon, it tapers west, going right up to the African West continent, and all moving all along this region, covering parts of China, northern part of Australia, and the South Asian region. And all this receives the monsoon rains. And how are you going to reconstruct it? So we picked up some of the lake sediments, and here in this panel, you see how the northeast monsoons behave and how the southwest warming currents go up, controlled by the ITCZ. I'm not going to go into the detail of this, but this is definitely a very dynamic system. All of us think that getting into the lake and going into the center of the lake, collecting the sediment core from the middle of the core is going to give you a complete data. But believe me, this is not true. Why lakes? And what are the different types of lakes? Number one, you have different origin of lakes. They are sometimes meteorite, they are lakes which have been formed due to meteorite impact. You have glacial lakes, volcanic lakes, coastal lakes because they are topographically in the low-lying nearby marine area. You have the internal lakes, depends on the size, depends on the chemical content. Sometimes you have lakes which have gone saline over a long period of time because of the evapotranspiration. For the best examples, you get from Rajasthan the Sambar or the Tal Chapar, etc. This is the lake that you get in Rajasthan, where they are bounded by the sand dunes, and you have the lakes which are now producing salt. Even Aurangzeb was collecting salt for his municipality from the Rajasthan Sambar and from Didwana lake. I mean, that's what the historical records go. But if you look up at the distribution of rainfall in this region, it tapers. It tapers more towards Jaisalmer region, getting around 150 or even less than 150 millimeters of average annual rainfall. And this definitely creates a dynamic system in the lake records. This is just to show you the lakes that are bounded by sand dunes, and this would have been a part, many people have worked in this region. They say that this would have been a part of an older drainage system which has got now narrowed down and become an isolated salt lake, part of the salt lake systems governed by the traces of faults and lineaments. Now, I have been working in Africa from 2010, and I look up at the Turkana lake system, and I've excavated several sections, more than 30 lithological sections in Turkana basin, and you find that everything stops at 8.2 kilo year. All the hills that you see there are all the evidences of Paleo lake, and it all stops around 8.2 kilo years. In India, it's the only region where you don't have a high lake level margin stopping at 8.2. That means there has been a seesaw interrelationship during the Holocene period as to what was happening in the rains of the southwest monsoon happening in Africa and in Rajasthan or in India. If Africa was getting very high rainfall during the early Holocene period, you do get some evidences in Rajasthan or in some other lakes which date up to early Holocene, getting good amount of rain, but certain intermittent period you get very less precipitation evidence for this in the Indian lakes. Now, why all this important? Why do I have to waste my entire life going and working in the tent and staying in a tent and working in Africa and working in India? The most interesting part is this, that the monsoons create a big interest in the entire population of this region. 6 billion population total in the world, out of which 4.5 are already in this part of our system in Asia and Southeast Asia. And the entire economy depends on the monsoonal rains. And it is also important to note that the civilizations like the Sumerian, the Akkadian, the Mesopotamian, all of them were already established. They were agriculture system very well established, minimum from 6,500 years from today. There are very good evidences. There are a number of sites which have been already well excavated, well dated, and published in both national and international journals. In India, what we get is, we have the evidence of pottery making going up to 5,500 years, and growing agriculture system of barley and millet also coming from the same time. So man was already well established on the riverbank system in India. And if you compare the scenario that is coming from 15,000 years onwards, right from different sites in Asia and mid part of Europe, Levant, for example, in Israel, they all go back very far behind, 15,000 years. But here in India, you get only evidence coming from 5,500 or maximum 6,000 years. And if you compare them with whatever record that you have, this tells you that even the temperature has moved. There is a variability in temperature going from different times. Last glacial maximum, the temperatures were quite hot and arid, and whereas you come more closer to the present, it's becoming slightly semi-arid in condition. Now, how do you do all this? And where do you get this data from? You get this data coming from marine core data, from lakes, from historical records. For example, the Roman warm period, in this around 200 BC to 200 AD. You get the Little Ice Age in Europe and China. The evidence of medieval warm period in between 10th and the 12th century AD. You have the Dark Ages also coming around this time, between the 4th century AD. So all this is very important to calculate and evaluate for looking up at the past, taking up the present situation, and calculating and modeling for future climate change, if there is any. And so, in India, if you look up at the review, one of the finest and pioneering work was carried out by Gurdeep Singh and his team, and they looked up at the salt lakes from Rajasthan, and they worked out how the Harappan civilization got extinct over a long period of time. But now, with Conde's work in scientific reports and with Enzel's work in 1999 on Lunkaran's Lake, we find that the Harappans continue to live in spite of climate change, draining away of the river system, and intense heat, intense climate change, intense dryness coming into the Rajasthan area. And there are several evidence, Somoriri Lake or the Sokar Lake, Lahur Deva, Berijim, Pukod, and several of them, and also the marine core taken from Bay of Bengal. There are evidences coming only in small patches. You don't get a long record, a long continuous record, but lot of discontinuous patches, probably because the sediment core that they retrieved from the lake were short and also dated by conventional radiocarbon dating method. But now, that if you look in the conclusions, when I show you, you'll be able to see that with the high resolution technique, there have been continuous records coming from different salt lakes, which have been used for reconstruction. So we looked up at the Veliani Lake, which is on the west coast in Kerala, and also the Pukod Lake in the Nilgiris. There are several other lakes like the Berijim, the Kukal, the Erkard Lake, which is coming near Salem, and all these lakes, they receive something like 1,700 to 1,800 millimeters of rainfall, whereas the Erkard Lake receives about 1,200 or even slightly less than that. So the main objective of studying a lake system or the limnological studies per se is where is the organic carbon or organic matter coming into the system? Is the lake producing its own organic carbon or organic matter, or is the organic matter coming from the nearby catchment area? And why this is important? This is important because the lakes are the major sinks for carbon element. Now, there are several. Now, this protocol is now very well established. You take a sediment core, you slice it up at very thin resolution, analyze it for various geophysical, chemical parameters, but then you can also supplement your data using geochemistry, palynology, diatoms, and of course you need radiocarbon dates or any dating system that you can place the sediment layering and accumulation over a period of time. Now, in all these studies, the most important contributions come from palynomorphs, and here I should put on record that BSIP has done a yeoman's service in training number of students in understanding palynological, generating palynological data. Now, just collecting data and inferring arid, dry, wet, or cold is not enough. You need to quantify those data. You need to bring a number on the system which is going to be relevant for using them in GCM or regional climate modeling, which can help you to predict future even for the next 30 to 50 years. One of the most, another important objective in studying South Indian lakes, southern Indian lakes from Nilgiris and Ooty area is also that why there is a dwindling of the Shola forest. This word Shola comes from the word called as Sholai, which means a canopy of vegetation. You go to Ooty today, it is full of eucalyptus. And eucalyptus does not belong to, is not an indigenous plant of our region. It comes from Australia. You take any plant even around you in Nagpur, you will see that many of them are not indigenous, but they have become invasive and they have already occupied the major terrain. So whatever pollen that you keep collecting and identifying in the lake system are all invasive plant material where people have brought in since the last 8,000 years back due to trade. And you know that the first boat was already made for trade. First ship for trade that came to India was much, much older, around 12 to 13,000 years from today. So people have been moving since then. And what you find here is that the Shola forest dwindled due to a number of reasons. And of course, anthropogenic pressure is the most, and reclamation of land for agriculture purpose. So what you do is pick up a sediment core, describe it, and describe it meticulously. And this is very important. What you describe? First thing, you need to have a Mansur color chart. I was listening to Firdaus talk on soil, and there was no description. You need to describe it. You need to say, what color is it? For you, what is brown need not be brown to me. What is light brown to you may be light yellow to me. So there is a standard program, there is a standard method which you should follow. You need to describe it following the Mansell color chart, which is worldwide, which is accepted worldwide. And then run your sediment analysis, pick up the layer which has a very high content of organic carbon or organic matter. There is genetically difference between organic matter and organic carbon. And therefore, you can use organic carbon to date, but you need to give a correction. But if you date organic carbon using AMS method, then you don't need to give correction, but you need to calibrate it for all the calendar years. Even you can calibrate it for Egyptian calendar. And what you find is this, that the sedimentation in the lake has not been a straight line, but then it has been, the sedimentation in the lake has taken place in phases. Now, I want to tell you all one thing, is that if you had a straight line from zero to the bottom, then it is a straight, a regular sedimentation. But if you have breaks like this, that means it has taken place in phases, or that there has been a break in the sedimentation. Now, this section comes from Berrigan Lake. And here you find that the dates, they go up to 3,000 years from today. Earlier, there was a senior researcher named Professor Vishnu Mitre from BSIP, and they have already worked on this region from the Berrigan Lake, but then they went up to 12,000 years by using radiocarbon conventional method. So what you can do is look up at the sand silt clay, and you see the wriggles going down with OM, CaCO3, TOC, and it's very important to take a ratio of carbon by nitrogen, and of course support it with delta C13, which is in per-mil notation. We took up a core from Parsons Valley Lake in Ooty, and it was a very short core, but it dated up to 29,000 and odd. But a very long core in Kukal gave us a date only of 7,000 years. So it's very clear that longer the core does not mean that you're going to get a very old date or a very later date, but you can also get a very old date in a very short core. And here you find that the organic matter in both the Kukal as well as the lakes that are located in Ooty, they are all coming, they have a very less proportion of mixed contribution coming from the catchment area, but they are all producing organic matter, organic carbon within the lake. Now here you see an array of pollen coming in, but what would be very important is to delineate when each pollen came into the system, or when each pollen plant became invasive or it is indigenous to this region. And just based on this, you can have a zonation, and all these zonations are demarcated as the first appearance of the pollen. Let me run through. This is the Pukod Lake. You find that This is a phytolith. There are different types of phytolith. The dates, they go up to 6,240 years. In the lower portion, you don't get phytoliths. That means that the sediments were not suitable for preserving phytoliths. And you know that phytoliths are siliceous in nature. Again, you see that the dates, they are very slow rate of deposition, few millimeters per year. An array of pollen data. You find Meliaceae. This is all not coming from indigenous from India. They're coming from elsewhere. You have Maduka. Yeah, yesterday someone was talking to me about Maduka, and it is, there are different species of Maduka, and this is one of them which you find in the Ooty area. You can do a number of chemical analysis, and you can normalize it with AL. This is Berigem Lake and Pukod Lake. And then when you compare all these lakes with the dates, you see that there are different events coming up, but different lakes have preserved their signature in the thickness and thinness of the sedimentation. It's to show you a bigger picture of this. Rubidium by strontium, CWI, chemical weathering of index, in all the three lakes, and all the various other chemical parameters show that the extreme events are preserved, but they are preserved in different lakes at different thickness, and the impact of these events have not been continuously the same. Okay. Can you give me 2 minutes, Professor? Okay. Now, looking up at the Arcad Lake, Aircard Lake in Salem, it receives the northeast monsoon, and the date goes up to 2572, when humans were already well established in this region. We took a core, you date them, and we wanted to find out where is the organic matter coming from in this lake. And we find N15 and delta C13. When you plot all of them vertically, and you see that and you plot them one against each other, you find that all of them cluster nearby, and they all show that it's an in situ production of the organic matter or the organic carbon within the lake itself. It is not coming from its catchment area, because the catchment area is quite nearby, and the material does not flow directly into the lake in a fast moment. This is again the Aircard Lake, and you see that the more terrestrial and fluvial contribution, and they all come with a freshwater dissolved oxygen carbon with very less amount of terrestrial derived organic matter. You can plot this, and you can easily delineate these organic matter source. Now, why this? Whatever you're doing on the land, it has to be in equilibrium with all the system around it. For example, if I take a marine core, this was retrieved by me using the ship from NIOT, and we took a core from landfall, near Landfall Island, dated it, and did all the various analysis that I showed you earlier, and compared it with Kunnaf Cave speleothem, with the DSDP core from 723A, and also the very important thing here, which I'm going to just spend a couple of minutes, is that the Ponton et al., 2011 until 2014, they brought out a very nice work on the Godavari Delta sediment core, and compared it with the Harappan civilization for its decline. And what they did was, they did not look up at the sediment delta C13, but they looked up at the leaf material wax of within the sediment core, and worked on the stable isotope, and they built up a complete story, a paleoclimatic resolution, high resolution study based on this work. Ponton et al., 2012. We also showed.
Now I would like to invite the next speaker. I think it's Pradeep Kumar Jain or Shamoli. Shamoli Sen. Shiva Kumar. Yes, sir.
Professors on the dais and off the dais, scientists, research scholars, students. Thanks for this opportunity. I'll be presenting on, identification of freshwater aquifers that lies beneath saline aquifers. This is one of the continuous projects we have been doing for Madras IIT as part of rural drinking water supply program. Many coastal villages in Nagapattinam and Ramanathapuram districts face drinking water problem. During, when Kaveri flows in Nagapattinam district, from July to, March, there is adequate water in the rural coastal villages. Once, the Kaveri flow stops, in the month of March, April and May, the coastal villages of Nagapattinam and Ramanathapuram districts face a lot of drinking water problem. So I'll share a few success stories wherein we have identified deeper freshwater aquifers using resistivity survey. So the objective of my study was to see the effectiveness of 1D resistivity survey, wherein we effectively identify freshwater aquifers that lie below saline aquifers. So this is the methodology we followed. We collected all regional data, well inventory data, then conduct resistivity survey to 300 meters depth. So interpret aquifers based on the resistivity data and summarize results with conclusions. So this is Kaveri data, Kaveri river that originates in Karnataka and it drains into the Bay of Bengal. You can see the site where we did the study, very close to the sea. Here, the shallow aquifers and the middle aquifers are saline. People can't tap the aquifers. When their water is there in Kaveri river, they can use the shallow aquifer. Once the river dries up, they face the problem. So this is the site where we did called the Velippalayam village in Nagapattinam district to locate freshwater aquifer. As I said, a lot of rivers drain to Bay of Bengal. So there are several distributaries of Kaveri that drain into the West Bengal, the Bay of Bengal. The rainfall is adequate in Nagapattinam district, about 123 centimeters a year, but still people in the coastal areas face water problem during the month of April, May and June. So close to the shore, it's a mix of the floodplain and the both fluvial and marine deposits mix. That's why we get kind of freshwater, saline water, and then again freshwater. So mainly it's sand, silt, clays, sandstones, and shales as we drill, into the aquifers, into the bore wells. So the formations belong to the recent and as well as the tertiary, mainly the Miocene and the Pliocene periods. So this is what I said. Mainly the aquifers belong to the Quaternary and the Tertiary period. So this problem, the aquifer 1, it's about 10 meter depth. Below 10 meter you have full of clays. And this aquifer lasts only up till March, April, May and June. It becomes dry. So people can't use the shallow source. So people can't afford to drill deeper boreholes. So once you cross 30 feet, it's full of saline water. So we collected data and we conducted resistivity survey using Schlumberger method. You all know what Schlumberger method is. So you have 4 electrodes wherein you have 2 outer electrodes and inner potential electrodes. We keep expanding the outer collector electrodes to improve the depth of penetration. So this is a field survey we collected. This was done for Madras IIT. So we used 1x 1D software to interpret this true restivity, with which we interpreted whether it's a freshwater aquifer or a saline aquifer. So 12 locations we did the survey. These are the survey locations. So you can see the range of values, all very low restivity values, indicating that it's saline water. But however, as you cross 240 meters, there is a slight increase in restivity, apparent restivity values, indicating that there are some chances for potential aquifers. So which we interpreted, and we drilled the borehole, and we got a freshwater borehole that was able to meet the drinking water supply of the villages. So this is a typical true restivity data, wherein if you're getting very low restivity value like this, it means it's predominantly clay deposits. So if you're getting below 1 meter, 180 meter, beyond 10 ohm meters or 20 ohm meters, then it means it's a freshwater, it's a sandstone that has fresh water. So you can see, so this is predominantly shale, wherein there is no aquifer. This kind of curve trends indicates that there is a freshwater aquifer here. So you can see here, beyond 200 meter depth, the apparent restivity, the true restivity is 20 ohm meters, that is below 200 meters, wherein you can look for freshwater resource. So like this we interpreted, and we drilled a bore at location 5 using rotary rig, and you can see up to 80 meter clay deposits. Then you have the marine sandstone with lot of shell fragments. So this all had very low restivity, and our data correlated well with the drilling data. And between 220 to 280 we got white sandstone, which we decided to install slots, and well construction was such that to avoid cross contamination of aquifers, we sealed to 240 meter depth with clay balls, and bottom we had the slots. Between 240 to 280 we had the slots to facilitate water enter the borehole casing, the well casing. And this was the well design we had 0 to 210 meter clay pack, 210 to 225 clay balls, and slot was between 240 to 280 meter depth. So this is the clay balls which you used to seal from surface to 240 meters. It was sealed, and when we developed the well, it gave a TDS of 1500 ppm and 30,000 liters per hour. And we were able to solve the drinking water problem of 4 villages. I can give the villages name. You can go and see. All were fishermen who are staying there, and all are using this water for domestic purpose. They are also using it for drinking and using RO. So thus restivity survey. With restivity survey, you can find out freshwater aquifers that lies below saline aquifers. This may be tried even in Rajasthan or many other areas to locate freshwater aquifers. So that's it. Thank you. We are doing for IIT, sir. Per point we are charging 12,000 rupees. Per location, 12,000.
If there is any more question, then only 1 or 2 questions are invited. Actually, we are also out of time. Thank you. If there is no question,
thank you.
I would like to thank Shiv Kumar sir for his nice presentation.
With this presentation, we come to an end of this 2-day seminar. After this, there will be a lunch. But before that, I would like to request Nigam sir to felicitate Professor Hema Achyutan ma'am for chairing the session and giving the keynote. Shukla sir to felicitate Dr. Bishwajit Thakur. Please to have lunch.